can. Okay? But they realized that actually integral is an even better symbol because it can find every little pieces from part A to part B. So Riemann sum, an improved version is to integrate from 0 to 1. Okay, this entire function. Then you can get the actual area under graph. So integration gets you area under graph. No need. This is how they started off until they finally realized actually you just integrate, you get the actual area under graph. So how to integrate this one? Plus x. And then just sub in 1 and 0. No plus c, So you get 1/3 plus 1 minus 0. So it's 4/3, which is 1.3 with a dot. So it is correct that this actual area is bigger. No need, actual is bigger. Correct. So actual is bigger than the estimated because the estimated never take into account all these parts. Right? So the estimated actually left out all these little parts, which explains why the actual is bigger. Okay, so no matter what, the estimation cannot be your actual. Sorry? Because this is the limit. I'm integrating from 0 to 1. Yeah. Yes. No. No more already. Next term then resume. Because now you are supposed to go into mother tongue intensive mode. Any one non-mother tongue student? So these people will see you all for math. I mean you do your June holiday homework first. Okay? June holiday homework first. Okay, don't complain.
We got higher mother tongue instead.
Oh yeah. So you need to take 2 papers. Sorry? So no need to take already. Yup. Not entire week lah. I will see some periods where there's math. Why? Complaining, is it?
Stop vandalizing my papers.
Yeah. I check. I have the all level one. Okay, I'm gonna show you how to do this. Okay, so first thing first. Okay, I'm gonna do first example with you. Second example, you will solve on your own. But this time round, we are going to explore the use of, what do you call that? What is that thing called? AI. Help you solve math problem. Okay, so first thing first, what is the given info in this example? Yeah, why my diagram keeps turning? Why my paper keeps turning? It's like, is somebody controlling my paper?
You should make the thing straight.
No, it's like I cannot turn. Then you see, it keeps turning on its own.
No, it's not. It's a go.
What happened?
This one is me, this one is good.
Okay, so let's write down the first thing. So those with the digital copy, you can write this down. The given info is like what Ane says, the equation.
Wow, you're so smart, yeah.
Okay, you might want to write it in this way. What other things that is given?
The
1, 2, 3. So it gives us the boundary limits. Okay, so for region A, they tell us that x is from 1 to x equals to 2. For region B, x is from 2 to x equals to 3. Any other info that they give us that is essential? No more? Okay, what is the output that I'm trying to find here? What is the output? Area. So area of region A, okay, and B respectively. So this is what I'm interested in finding. Okay, then what do you think is the theory that we need to use in this example? Yes. The infinity one. Integral. So integrating from A to B, the function with respect to x is equals to area under curve. Okay, so this is the theory that we need to use if we are suggesting to find area under curve. So what is the solution essentially that we need to solve this? So how do we make use of AI to help us ask ourselves questions when we are stuck?
I can get everything right. It's just like during the exam the AI will function.
Okay, let's just try. So this is the step that we do to perform integration of cosine 2x minus pi over 6. Okay, and then of course you ask yourself, what are the boundary limits? For the shaded region. So you will integrate from 0 to pi over 3. So these are the questions that should happen in your mind. And then you perform your integration. So integrate cosine gets back sine. Same expression. But you must divide by the differentiation of the expression inside, which is 2. Because this thing, if you go and integrate, if you go and differentiate, it's just 2. And then remember, you need to sub in your pi over 3 and 0. Divide ma, integrate with divide. Differentiate, then you multiply by the differentiation ma, but integrate you divide. Okay, so this will help you. Oh, I used the wrong shape. Okay, I used the wrong shape. Parallelogram means input output. Rectangle is the process of getting to the answer. So these are computing language. Okay, so after you put in, okay, you must learn how to substitute the limits to get the definite integral.
Is that boundary units?
Boundary limits, yeah.
Okay.
The upper and lower limit. Like from here, this is the lower limit. This is the upper one. Okay, it's bounded. Can you see the area is bounded from 0 to pi over 3? Okay, so to get your final answer, you will end up having sine 0, right? Then minus, what is sine? Pi over 6 is what? 30 degree. Negative half. Okay, you just key in the pi over 3 into the fraction, then this is what you get. Your answer would be, this is the output, 1 over 4 unit square for area under curve. This is your part B's answer. So this is your output. Okay, so there are some questions that you can learn to ask yourself, okay, to help you to solve the question. This one? Okay, remember when we differentiate sine we get cosine. And then we must multiply by the differentiation of the fraction inside. But now we are integrating. So when you integrate, you get back the sign. Then you must divide by the differentiation. It's the opposite. The differentiation of 2x. There's no power what? For trigo, when you differentiate, there's no power. Yeah, so sine, cosine, tangent. Only tangent when you differentiate, you get secant square. But the rest is all without power. Can Okay? So this is the series of steps that you should practice when you go back home. When you generate a series of questions from AI, you need to know what the question is asking so you know what to sub in. It's not just about solving. These are the steps that you should ask yourself when you solve the problem. So if you don't have this kind of questions in your mind, you will always be stuck with solving problem. Okay, so it's a good practice. Every time you are stuck with a problem, go to AI, ask them to generate some questions to help you solve this question. And then look at the questions they ask and try to answer them. Then it will help you to solve the question. So you need to do this one first. So you need to integrate from half to 1, this part of the curve. Okay, but take note, you already anticipate that they are going to give you a negative answer. So earlier on when you learn modulus, right? You learn that you will drop the sign, okay, and then straight away make it positive. But if you don't want to use the modulus sign, then I will encourage you to put a negative sign in front so that it will make your answer positive. So I leave it to you what you prefer, but I personally like to write this. Okay? Then there's a second half that I need to integrate, which is from 1 to 5. The same expression. Okay? So take note, you need to split because this is a negative area since it's under the x-axis. So everything else is the same. So if you integrate this thing, you get x. This, if you write it easier, it's like that. So how to integrate the minus part? You add 1 to the power, divide by new power. And then you sub in your 1 and your half. And remember to remove the negative sign later. This double line is called the modulus sign. It will remove the negative value. Okay, then this part, same thing. You're going to get the same expression. Okay, and then you sub in 5 and 1. So we double check. This is 1 plus 1. Okay, you sub in. This one, this expression, if you simplify, you end up getting like that. Okay, the simplified form is like that. That's why I'm writing it this way. Okay, same thing. If you simplify this is your expression. So if you sub in, you get 5 plus 1/5 minus 1 plus 1. So if you check, this is 2 minus 2.5. Can you see that it gives you a negative half? So remember, when you write your answer, you drop the negative part, you just write half only. Because the modulus sign ignores the negative part. You're finding total area. So you don't care above or below, you just want to know that this area here is 0.5. The negative tells me it's below, but I want to find total area. Okay, then this part here, minus 2, so 3.2. So your final answer is a 3.7 unit square. Okay, so if you don't do it carefully, you will end up having your answer as a 2.7. Okay, so I just want to remind you that when you get your answer here as minus half, the modulus sign removes the negative sign and make it positive. Okay, because you want to find total area, not the one that is cancelled off. Okay? So everything else you have learned before is just look at the diagram and see whether you need to split them or not.
So I got minus half.
You got minus, yeah, so the modular sign tells you to remove the minus. Change it to positive.
Yeah, going to be short.
We only have this short time. 11:05, right?
So I kind of sleepy.
What time my lesson end?
11:05.
Yeah, it's ending soon. You ask me short break, then later it's gone already. You always cheat me.
3-minute break.
Okay, no. This one, there are two ways. Shh. There are two ways to do this question. First is split it into two parts. Okay, look at it carefully. If you split it into two parts, this region 1 is a rectangle. So how to find the area of that rectangle? This length is 3, right? But what's the breadth? How you know? You cannot guess, you know?
Minus 1.
No, how to find this x value?
Oh, the x value.
I know the y here is 4. So you go and sub in 4. Then x is just 1 or negative 1. So you reject the negative because it is at the positive part. So this first part, this region 1, is 3 times 1. So it's 3 units square. Okay? But I also want to find this part. So by right, I should find the integral. Okay, the region 2. I want to find this region 2. So I must integrate this expression from where to where? From 1 to 2. But I will end up having that whole slice.
So you just minus that white part.
Minus that little rectangle that you see there, which is a 1 unit square. So if you want to do it this way, you need to be careful which part of the diagram you are interested in. So this will end up having minus 1 divided by minus, sub in 2 and 1. So you end up having minus 4 over 2. So minus 2 plus 4, 2. So you get 1 unit square. Okay, so what is the total shaded area?
So it's 3 plus 1.
Yes, the 3 here and the 1 here. So 4 units square. So this is if you stick to integrating with respect to x. But actually, right, you can also choose to integrate with respect to y. Let me reverse the diagram for you. That means let me chip this out and turn the diagram. Okay, so you can look at the diagram in this way. You see, I just did a turn. I just knock the diagram down, turn it in anti-clockwise direction. Can you see that you can also integrate from 1 to 4? Can you see that?
Yeah.
But now it's with respect to the y-axis. So by right, this equation, you must make x the subject of formula. So how to do that? I will rearrange them. So swap the position of these two. And then I take a square root. Okay, when I take a square root, right, you will end up having this. Two different expressions. But if you look at this, is it above or below? So we don't want this. Because according to the graph, I'm only interested in the graph above. So I need to learn how to integrate this later. So I write it in a way that is easy to integrate. So this is my new expression. Instead of using this, I should rewrite my expression as this. Then I only have one single step, which is to integrate from 1 to 4. This expression only. and I should get the same answer. But take note, is with respect to y now. Just now it was all with respect to x, but now we are integrating with respect to y. So everything else is the same. Add 1 to the power, divide by new power, you sub in. So you end up having 4y half. So you get 8 minus 4, also 4 units square. So this is neat, but you need to make sure this formula you do correctly. Then in one step, you can get the answer. But what I showed you earlier is if you don't want to change the formula, you can still integrate with respect to x. Just minus off the rectangle, the whatever shape you see. Okay, so you see which method you like better. Both are equally good. This is with respect to x. This part here is with respect to y-axis. Okay, so the entire area part is just take note whether got above, below. If it's below, put modular sign. If it's with respect to y-axis, you must make x the subject of formula. So these are just some things to take note of. Otherwise, your integration concept, there's nothing new here. So no matter how they do this, don't be scared. It's all the same old thing. What? Can. Okay, this is example 5. Can I just challenge you to try it on your own? Question 5. You just need to come up with a way to split the diagram. And tell me what do you think you will do here. Look at the formula in the first place. They give you x equals to something. So what do you think you are expected to do? You should flip the diagram in this way. It's like as if the diagram looks like that. Okay, because you are supposed to integrate with respect to y-axis. That's why they give you your equation in terms of y. So how will you integrate? Should you split the diagram up?
No.
Why not?
You can just use 2, 0.
From here, but my curve is not here. My curve is only starting from here. So if I want to find area under graph, I need to find what is this value of y first. Then I integrate from 0 to this value. Then I can find area under curve for this part. But what about this yellow part? Half times base times height, that's all. Because this is a triangle, it's under a straight line. So not everything integrate under the curve, only this part. Can you see this part is under the curve? You just need to be able to integrate from 0 to this value. How to find this point? Sub what? Sub x and 0?
Stop y.
Sub y at 0? No. This line is, this point is the intersection between what and what? The line and the curve. So I know the curve already. How to find this line? Go and find y equals to mx plus c. Find the equation of mn. Then equation 1, equation 2, solve for this point. So the moment you solve for this point already, then solving shouldn't be a problem. So I do a very quick one. Gradient of mn is 0 minus 2, 4 minus 0. So it's minus half. Okay, I choose one point, y minus 2, x minus 0. So this is my equation. This is equation Mn. Okay, so equation 1 sub into equation 2. I end up having okay, so try to solve this. So you have x equals to 10 and x equals to 2. So what should the x be? Cannot be 10, right? It's too far off because I think there's another point that cuts here. But we are not interested in that. So this one reject. This must be 2. Okay, so the moment this is 2, then you can go and find your y. So the point intersection is 2, 1. So this point here is 1. Okay? So with that, you can now find your area. Area. Area is the triangle. This base is 1, right? 1 unit. This height is 2. Okay, then you also want to find the area under the curve from y equals to 0 to y equals to 1. So go and find half times base times height. Go and integrate the curve with respect to y from 0 to 1. So total is 2 and 1/3 unit square. Okay, so I hope you don't find this scary. It is just always the same thing. So if you want, you can try the rest of the example. It should be very doable. But of course, I have shortcuts to teach you. But that is the next. Do I still see you all? No more. Okay, so yeah, if you can this holiday, go and try the other examples. When you come back, we'll wrap it up. Okay, can you do me a favor? Okay, let's practice using AI to. It looks scary,